Hello, and welcome to this video on the operation of the PVML-HSX1 conversion license for the PVM-X series of 4K HDR video monitors. My name is Andy Munitz of Sony's Professional Monitor Product Management Team.
And I am Hugo Gaglioni, Sony's Chief Technology Officer for Broadcast Products. With the advent of high dynamic range for use in ultra-high definition formats, there is a demand for simultaneous creation of HDR and SDR masters from a single production workflow operating in HDR. This requirement also gives rise to different criteria for adjusting the live production cameras based on shading either the HDR signal or the converted SDR signal. Therefore, this HDR production workflow requires not only conversion devices for the creation of separate HDR and SDR production elements, but also requires the use of monitoring devices with the necessary EOTFs, or electro-optical transfer functions, for display of the various HDR and SDR signals. In this video, we will examine an optional conversion license, the PVML-HSX1, for use with our PVM-X series of 4K HDR monitors, which implements this HDR to SDR conversion techniques. The use of this conversion license activates a unique HDR-SDR conversion engine with algorithms originally designed for our flagship broadcast converter, the HDR-4000. These algorithms are now implemented in FPGA form inside these monitors. In addition to HDR-SDR conversion, the license will enable the following functions: 4K to HD down conversion, 1080p to 1080i conversion, quad split 4K signal into a single cable 12G format, and a process output via the enhanced monitor output, which can include the converted or baked-in LUT version of your program material. The HDR curves that are supported by the PVML-HSX1 conversion license are HLG, or hybrid log gamma, S-log3, and PQ curves.
So, let's begin this demonstration by examining how to use the menu in the HDR conversion process in the PVM-X monitor by simply selecting some of the conversion presets already pre-programmed in the monitor. By the way, since you're watching this video over the internet, you won't be able to see the real benefits of HDR images that we'll be working with. So an accurate evaluation of the HDR to SDR conversion from this video is not really something that you should expect. In our example here, we'll be feeding an HD HDR HLG signal from our PMW PZ1 player. To begin, let's set up some of our front panel function buttons to make this process easier. Go to the main menu's FN, or function page, and assign F1 to channel 1, F2 to channel 2, F3 to conversion, F4 to side-by-side, and F5 to quad view. We can confirm these settings by simply pushing the monitor's Select Enter knob, and the assigned values will be shown on the screen. Next, select from the User Preset Setting menu the Channel Setting menu and go to channel number 1. Turn the selection knob left to get to the second page, and copy from channel 6, HD HLG 3G, and turn the knob right back to the first page to confirm the HD HLG 3G setting. Notice that on page 2 of channel 1's channel setting page, there's a setting for conversion preset that has 10 pre-configured choices. 9 of them are for HLG signals, and number 10 is for an S-log3 input. These are pre-configured in this manner because the HLG and S-log3 are the most used HDR curves for live production applications, but they can all be reconfigured as desired. For this demonstration, set this conversion preset to preset 3. For more cinema-related applications, we can select any one of these presets and change the value of the EOTF in the channel setting from HLG or S-log3 to PQ in order to process an HDR PQ conversion to SDR. When looking at the final SDR converted signal, scrolling through these presets will change the look of the conversion. If you want to further modify any of these presets, though, you must go to the actual conversion preset menu, update, and then store the new settings. Values for each of these presets can be found in the ops manual, by the way. Some of the common settings in the conversion preset menu are included in the conversion mode: SR-Air off or on, which means scene referred artistic intent rendering, and display referred. When SR-Air on is selected, this enables a choice of HDR looks, where you can adjust from mild to live for a punchier look. Natural appears softer than mild. These selections will provide different levels of saturation to the resulting SDR signal. Note, by the way, that there are a total of 4 pages in this conversion preset menu. So let's continue on for the conversion setup. Go to the multi-view menu and select the side-by-side menu and set Screen A and Screen B both to Channel 1. In our case, they should both say Input Select 2K SDI Input 1. Press function F1 to look at the incoming HLG signal. Then press F3, Conversion, to flip between the HDR and SDR versions. Press F4 if you want to see both HDR and SDR versions in side-by-side mode. Note, if you hit F3 at this point, you will see the left side of the screen change between the original HDR input and the converted SDR image. To use the Enhanced Monitor Out, or EMO, connect it to another monitor. Set up that monitor for an SDR BT709 input with its corresponding color gamut, BT709, and transfer matrix, BT709. And when the conversion function is turned on in the main monitor, it will display the SDR converted image on that second monitor. Note though, if the conversion function is set to off, the second monitor will show the HDR HLG signal, but placed in an SDR 709 container, and will not look correct. So far, we've been doing HD HDR HLG to HD SDR conversion. However, you can also execute a 4K HLG to 4K SDR conversion, and also use the enhanced monitor output to send this converted signal via 12G over to another monitor if it is also set to view 4K SDR 12G. Also, we've been only talking about live production and conversion from HLG or S-Log3 into SDR 709. As mentioned earlier, but worth repeating, for a different class of applications, such as on-set or movie production, one can set the EOTF for PQ, ST2084, in the Channel Setting menu, corresponding to a PQ input source, and to show its conversion to SDR 709. To do this, same as before, set up your input EOTF in Channel 1 to SMPTE ST2084. Well, that's it for the PVM-X's built-in conversion engine setup. Now let's have a look at how to properly set up the PVM-X monitor for a simple LUT-based conversion of your image. You can apply the LUT data to your signal input to display on the screen, or you can output the rendered signal as an SDI signal from the Enhanced Monitor Out connector with the optional PVML-HSX1, SCX1, or TDX1 licenses. In our case, in this demonstration, we will again be working from an HD HLG HDR signal. Understand, by the way, that the PVM-X monitor does not allow for taking a signal in and then using its looped-through output to feed into another input. So let's set things up. First, it's necessary to load a particular LUT into the monitor. You have 30 distinct memories for storing LUTs, and they are loaded into the monitor through the front panel USB port. Of course, there are some simple syntax rules to follow for naming and loading of these LUTs, so please refer to the operations manual for this information. For our example here, we are using a LUT developed by Sony, which is one among a family of LUTs we call SR Live LUTs, which have the added benefit of providing the user with different looks, live, natural, or mild, in the converted image. Once the LUT is loaded onto a FAT32 formatted USB thumb drive and inserted into the USB connector on the front of the monitor, go to the User Preset Setting menu and then to the User LUT menu. There you can save any of your stored LUTs into any of the 30 available LUT memories in the monitor. Now, for setting up the monitor. In our case, we'll make it so that we can look at both the original signal and the LUT converted version either alternately in full screen mode or in a quad view mode where we can see them side by side and also have appropriate scopes below each one. So in the channel setting menu, let's go to channel 1. Now, since we're working from an HLG HDR source, again, it can be easy to set up channel 1 by copying a setting that's already configured for channel 6 in the monitor's default presets. Simply turn the knob left to go to the second page of this channel setting menu and copy from channel 6, HD HLG 3G, by clicking in. And then turn the knob right again back to channel setting page 1 to confirm it was set to HD HLG 3G. In this case, notice that the EOTF is set for BT2100 HLG, and the color space and transfer matrix are both set for BT2020. Next, go to channel 2, and this time copy from channel 10. Copying this setting will allow for inputting a 2K SDI signal and will automatically change its EOTF to 2.4 and the color space and transfer matrix both to BT709. Back on the first page of this menu, change the input select to the input from connector 2, for us here, 2K SDI input 2. Then, to apply the LUT for channel 2's view, change the user LUT setting to the desired LUT file location. Next, go to the Multi-View Main menu selection and choose Quad View. Set screen A to channel 1, set screen B to channel 2, set screen C to scope, screen A, and screen D to scope, screen B. Next, go to the FN or Function menu and confirm that F5 is assigned to Quad View. If not already assigned, it's a good idea to also assign one of the function buttons to WFM or Waveform Monitor. For us here, go to the Monitoring Tool menu, then to the Scopes menu, and turn on all three choices of WFM, Vector Scope, and Color Gamut Scope. In the WFM vs CGS menu, we've also set the Waveform Monitor setting menu to be on RGB Parade, with its WFM highlight set to high and overrange settings turned on. Also, we've adjusted the intensity and transparency of the scope setting, but this can be easily changed for use when shooting, for example. Back in the User Preset Setting menu, go to the Advanced Preset menu, and in the User LUT range, change Auto to Off, Input to No Scaling, and Output to No Scaling Limited. When playing the file by selecting F1, you can see the original view of the HLG HDR clip, and by pressing F2, you'll be able to see the LUT converted image. To see both images at the same time, turn on the Quad View F5 button. Turning on your Scopes function button will also let you see the appropriate assigned scopes below each version of your image. Well, that's it for the LUT conversion view. Note, by the way, that LUT conversion is static. This is true for all 3D LUTs, and as such, they do not change if the picture changes from light to dark during shooting, for example.
A method for doing a dynamically changing conversion is through the use of SR Live metadata, which can change with up to 26 different camera settings. SR Live HDR workflows include up to 26 parameters sent from the acquisition cameras and transmitted as metadata over the banks of SDI connections that describe their adjustment at a given shooting condition. In the PVM-X HDR-SDR conversion, without the help of SR Live metadata, only a few parameters can be changed in the conversion. The HDR look, live, mild, natural, which are known as system gamma changes. Live is vivid, mild is a medium look, and natural is a bit weaker than mild. The other adjustable parameter is SDR gain, which changes the dynamic range of the system in conversion from HDR to SDR. Other minor adjustments can be made in the HDR conversion, such as calibration of the knee, which is like a roll-off effect on the highlight of the converted SDR signal. These three settings, HDR look, SDR gain, and knee, can produce about 90% of the accuracy of the HDR to SDR down conversion. Having access to the SR Live metadata enables the PVM-X conversion engine to precisely replicate an SDR signal equal to that created by the CCU of the camera during the live HDR production. In the PVM-X HDR conversion with SR Live metadata activated, these down conversion parameters are automatically set along with more detailed adjustments representing the settings of the camera. The only action required is to activate the SR Live auto parameter in the main channel setting menu, while all other changes such as OETF, EOTF, etc. on the input and output channels remain set in the same manner as explained in the previous modes of conversion.
Well, we hope this brief presentation has been useful for the demonstration of some of the capabilities that Sony provides in this new HDR-SDR conversion license for use in our family of PVM-X broadcasting monitors.
For more information on our PVM-X series of monitors or of any of our professional monitors, please go to pro.sony/PVMX.
And thanks for watching.